ಸರ್ ತೆಗೆದ್ರಿಂದ ಅನ್ಕೋತೀನಿ ನೀವು ತೆಗೆದ್ರಿಂದ ಅನ್ಕೋತೀನಿ ನಾನು ಅಷ್ಟೇ. ಹಾಂ ಸರ್. ಸರ್ ಹೆಂಗಿದೆ? ಇದು ಬಂದೆ ಸರ್ ನಮ್ಗೆ. ಸರ್ ಸ್ಕ್ರೀನ್ ಕಾಣಿಸ್ತಿದೆ. ಸ್ಕ್ರೀನ್ ಕಾಣಿಸ್ತಿದೆ, ಸ್ಲೈಡ್ ಶೋ ಆನ್ ಮಾಡ್ಕೊಡ್ತಾರೆ. ಸರ್ ಹಾಗೆ ಬಂದಿದೆ ಬಂದಿದೆ. ಸ್ಲೈಡ್ ಚೇಂಜ್ ಮಾಡಿ ಸರ್, ಒಂದು ಸ್ಲೈಡ್ ಕೆಳಗೆ ಮಾಡಿ ಸರ್. ನೆಕ್ಸ್ಟ್ ಸ್ಲೈಡ್ ಆಗ್ತಿದೆ ಸರ್. ಓಕೆ ಸರ್. Good morning. Start my Good afternoon. Am I audible? Am I audible?
Yes, sir, it's audible.
So today we are on the second day of our workshop entitled Geohydrological Engineering. So we have a very good speaker today, Dr. Syed Ashfaq sir. So it gives me immense pleasure to introduce him because he is one of such persons in the country who has a lot of experience and work on the remote sensing and GIS. So Ashfaq sir was born on 28/1/1965 in Gola, Bangalore today. So he completed his BSc and MSc and also even PhD from Bangalore University. So his distinctions were second rank in MSc in the Bangalore University during 1988. Also, sir, ಇದೆ. ನಾನು ಮಾಡೀನಿ ಸರ್ ನಾನು ಹೆಡ್ಫೋನ್ ಹಾಕೋತೀನಿ ಸರ್. ಹೌದು ಅನ್ಮ್ಯೂಟ್ ನೀವು ಮೈಕ್ ಆನ್ ಮಾಡ್ಕೊಂಡು ಕೇಳುತ್ತೆ ಸರ್. ನಿಮ್ಮ ವಿಡಿಯೋ ಬಂದಿದೆ. ಹ್ಮ್ ನನಗೆ ಇದು ಕೇಳಿಸ್ತಿಲ್ಲ ಸರ್. ಅಂದ್ರೆ ಫೋನ್ ಕೇಳಿಸ್ಕೋಬೋದು. So he got second rank in university from Bangalore University during 1988. So he was awarded the Young Scientist Fellowship from Charles University, Czechoslovakia, Prague in 1990, and he also visited Czechoslovakia and registered. He was awarded the Senior Research Fellowship from CSIR, Government of India from 1993 to 1996. He was awarded Commonwealth Fellowships, that is in 2002, from United Kingdom, where he visited the United Kingdom from 1/12/2000 to 2/6/2003. So he was nominated for the award by the University Grant Distribution, Government of India and Cultural Exchange Program to visit Syria for promoting Indian heritage and technical, physical and applied sciences in the year 2003. He visited the University of Cambridge under an exchange program from June 2015 to April 2016. So his area of specialization is remote sensing applications and image processing. So he is member in many of the professional bodies like member of Remote Sensing and Photogrammetry Society UK and member of Geological Society of India. So it includes he was director planning, monitoring and evaluation for PME from June 2016 onwards in Colombo University. He is a NAC steering committee coordinator. He is head of department of geology in Colombo University. He is the chairman of DOS Department of Geology, Colombo University from 2015. He is director of School of Earth and Environmental Studies. He is chairman of various local inquiry committees for college affiliations. So again, in Central University of Karnataka, he has played a very major role in setting up the many reputed distinguished laboratories in the Central University of Karnataka. He was the chairman of Department of Geology. He was chairman Board of Studies in Geology. He was dean in School of Earth Sciences, dean in School of Physical Sciences, dean in School of Computer Sciences, dean of School of Engineering, dean of Students Welfare, NAC Steering Committee Coordinator, and also was in charge control of examinations. So his work experience at Central University of Karnataka include he established new well-equipped departments of geology, physics, mathematics, computer science, and engineering. He prepared and submitted 12th plan report for Central University of Karnataka. He is involved in overall planning and development of Central University of Karnataka from 12 to 15. So his research experience includes he has 6 PhDs completed and 1 has been submitted, and presently he is guiding 2 students for their PhDs. So major area of the funding, that is around more than 1 crore rupees, has been brought by him under various grants of UGC and DST as the investigator and co-investigator as principal investigator. So he has been a coordinator for the UGC SAP DLS1 from the UGC SAP DLS2 and also DST FIST. So he has more than 15 publications in peer-reviewed journals, and he has contributed for 2 books and also has full papers published in the preceding volumes of 17 numbers. So it gives me immense pleasure introducing such a wonderful personality. Yes, he was a teacher to me, he was a guide to me, and a guru to me, and he has learned a lot from him. So I welcome you, sir, for this workshop. I hope that the participants will be benefited by the vast area of experience that you have in remote sensing and image processing. So I hand over the stage to you, sir.
Thank you very much, Ganesh, for your kind words. Can all of you hear me?
Yes, sir, you are audible, sir.
am I audible?
Yes, sir, yes, sir, you're audible.
Yeah, good. And I thank Dr. Ganesh Prasanna for giving me this opportunity to share my whatever knowledge I have with all of you. And I will be talking about the remote sensing applications in water resources. I hope most of you might have worked on remote sensing aspects, and I am going to concentrate on these two. Now, I am going to share my presentation with all of you. Can you see this screen, all of you, please?
Yes, sir.
Yes, sir.
Can you see? Yeah.
Yes, sir. Visible, sir.
Shall I start?
Yes, sir, yes, sir. You can.
Yeah. With your permission, I will start my presentation.
Sure, sir, sure, sir.
And I thank Ganesh Prasanna for introducing me with his kind words. And I will be concentrating on three, four aspects here on the remote sensing applications of water resources. And you all know the water resources, the present day condition of water resources in India, and also a lot of conflicts going on about the management of water resources. For example, the Karnataka and Tamil Nadu regarding Kaveri dispute, and so many other, every state. And now in future, we have to manage these water resources efficiently. Therefore, this as one of the very important tool in remote sensing. So I will be discussing about the theoretical part, and I will take up some case studies, what we have done on the management of water resources. And I will be concentrating on watershed management and if possible, command area management and the utilization of water resources within the watershed. So with all of your permission, I will start with my presentation. You all know the presence of water on the surface of the earth. Almost 74% of the water is in the form of oceans and seas, and remaining 3% is the fresh water that is available to us, out of which, most of the water, fresh water, around 2.2% out of 3% is in the form of permanent ice caps, which we cannot use them, and only 0.02% of the fresh water is available to us in the form of rivers, lakes, streams, reservoirs, so on and so forth. And another 0.6% is available in the form of groundwater, which we are tapping in our country, especially in Karnataka. And also we have some percentage of water in the atmosphere in the form of water vapor, in the form of cloud that constitute around 0.001%. With the presence of this, very small amount of water with us, we should manage it very properly. And to start with, the water resources here, when we take up the remote sensing applications of water resources, we all depend upon the satellite images. And we know the satellite, they are present around 900, 700, 600 kilometers above the ground level. And they work on the natural light from the sun, and also the artificial, we have the radars which generate their own energy and which send the energy from the satellite to the earth and then return back, and they measure the feature they have, the energy that is obtained from the sun. And I'm not going to touch upon the radar applications, microwave applications. So with this, the sun's energy, when we have the satellite images interacting the, sun's radiation, and part of the radiations you can see here in this diagram, Many of the radiations coming from the sun interact within the atmosphere and it return back. It never comes to the surface of the earth. And some portion of the radiation, they come to the surface of the earth and interact with the surface. And some they will penetrate into the water and some even deeper levels of the water. So these are the radiations which we are going to target. And of course, the atmospheric studies, we have a lot of that. What you see LP, with that application, we have lots of satellite images which can work on this property, and a number of satellites which work on the surface and which can also work on the water, the radiation that penetrates into the water body, and some radiations which goes to the bottom of the water body. So let us concentrate on this one by one. For example, this first radiation, LP. So this radiation, it records from the surface, that is the radiance. It interacts with the, atmospheric particles. Even, for example, the presence of gases like carbon dioxide, sulfur dioxide, nitrous oxides, all those things, you can record them directly from the atmosphere. And the LS, the surface radiance, which reaches the surface just on the boundary of the water, and that can also be studied. And LV, that the volume of the water can be studied. And in that, we can see the organic and inorganic constituent measurement, that I will come to it in detail. And also finally the LV, which goes to the bottom of the water body. So with this introduction, with this energy interaction, we can do a lot of work on these aspects. And let us concentrate what are the wavelengths we are going to target. So normally, for the study of water resources and also even the pond, we consider the wavelength starting from 740 up to 2500 nanometers. Most of the radiations, they start from visible wavelength to near infrared, mid infrared, and thermal infrared radiations. And there are so many applications within this wavelength between 740 and 2500 nanometers. And in this, we have the near infrared, mid infrared, and where from these radiations, we can delineate the water bodies and the properties of water bodies, physical and chemical properties of water bodies. And later on, I'm going to concentrate on the watershed development and management. That is entirely different study. And the water penetration, you can see the penetration of water. There are three different diagrams here. And at the bottom, if you can see here, there are three different wavelengths, one in green wavelength, one in red wavelength, and another one is NIR. So with these three different wavelengths, you can see the distinction between the water as well as the land. You can see this is the land. If you can see my cursor here, and this is the water body, which can be clearly delineated in near infrared region. Okay, whereas the other regions, the land you can see simultaneously with the water. You can see the penetrating power of this red wavelength. And also you can see the wavelength, green wavelength, wherein you can see the bottom of the ocean, bottom of the sea, up to certain extent. You can see the bottom here, and you can see some here. And in NIR, because NIR is a special property where the water absorbs almost all NIR wavelength, near infrared region. So therefore, we cannot see anything in the bottom. Whereas in the red and green, you can see the bottom, what is there present within the water body. And the response of the water body, once if the radiation penetrates here, in this diagram, in these two diagrams, once if it penetrates, what are the properties you can study within that? See, we have that radiation, which we can study the concentration of pure water, inorganic suspended sediments like minerals, organic minerals, dissolved organic matter. All these properties we can study with the help of remote sensing applications. For example, if I can take the radiant energy, the concentration of pure water. Pure water, we have seen pure water. It interacts with near infrared energy. Almost all radiation is absorbed. And once if the water body, if we have any suspended minerals, suspended matters, like clay particles, sand particles, lot of water bodies, they carry lot of this, suspended minerals in the form of clay and in the form of sand. So those can be studied very clearly. And in some extent, you can study the physico-chemical properties of water, like the presence or absence of organic matter, that is chlorophyll. There is a lot of applications of this chlorophyll, presence or absence of chlorophyll, especially for the fishermen. You can alert the fishermen where the fishes are available. These phytoplanktons are eaten by other planktons, and fishes, they are fond of this, and they will be concentrated in these regions. So every time we have special satellite sensors for this. You can map the presence or absence of organic chlorophyll within the ocean surface, subsurface. Likewise, we can study the dissolved organic material and also the other properties, which I am going to take up one by one here. So in case of minerals, a lot of minerals, water bodies, even freshwater bodies like rivers, when they are flowing, they carry a lot of sediments. You might have seen the siltation in the tanks and dams. A lot of this material, they come from erosion. So these things, they carry silica, aluminium, iron oxides. These are the most commonly found suspended minerals in any kind of natural water. So these particle sizes, they all vary from sand to fine clay particles, and also depending on the size of the particle, you will see the color. Nowadays, we are living in a region where we have a lot of rainfall, and we have two rivers in Shumaga. One is Tunga and Bhadra River. During this season, it carries lots of sediments. Wherever, if we open our tap, we get brown muddy water. What is that brown muddy water? It contains a lot of clay minerals, which cannot be settled down so easily. And also along with that, we carry a lot of sediments and lot of sand grade, fine grain particles. All those things you can study very clearly from this thing. One image I have taken from the shuttle radar. So this, you can see the presence of suspended sediments. This is the mouth of Mississippi River. And likewise, every river, if the river joining the ocean, this type of features you can very clearly see. You can download satellite images, number of satellite images available freely. You can download them and study them. So this is the mouth of the Mississippi River joining the ocean, and you can very clearly see these suspended sediments, how big, how far they are spread. So this is one such image. You can study them, the presence or absence of suspended minerals. Along with this, other properties, what we can study. So we have different wavelengths here, starting from 400 to 900 nanometers. And if the water is very clear, so their reflectance will be different. Percentage of reflectance will be different. And you can imagine the presence or absence of the sediment, suspended sediments. You can see 1000 mg per liter. If we have milligram, 1000 milligram, that is almost 1 gram. 1 gram of suspended minerals in water. So how the properties will differ and how the reflectance, how the other properties will differ, you can see in this diagram. Along with the wavelength, if the wavelength is increasing, you can see the different properties of reflectance and absorption. Based on these studies, you can very clearly demarcate the presence or absence of the fine sediments and clay particles and silt grade materials. So likewise, you can see the presence of clay particles, the presence of silt and soil particles, whereas the clear water, the reflectance remains same, almost near to the percentage 1% or 2% nearly. So that remains same, and along with the wavelength, they almost behave similarly, whether it is clay particles or silt particles. You can see the different absorption and reflection in the region of different wavelength and red and just near infrared regions. So these are the properties you can study using the suspended minerals. Likewise, we have the organic constituent. What are the organic constituents generally we come across the water? So we have the phytoplanktons. These phytoplanktons, these are the algal plants, animals which are present in any kind of fresh water, in rivers, in oceans, everywhere you can see them. And also animal planktons called zooplanktons. And also we have bacterioplanktons and the lower plant forms such as algal and fungal characteristic features. So these phytoplanktons are sometimes, majority of the times, They are single-celled plant organisms, small organisms, which have the photosynthetic capacity, whereas the zooplankton, they eat on the phytoplanktons, and likewise, you can study them very clearly if they are if their presence or absence in the ocean. And mainly, to study these phytoplanktons, we mostly depend on the presence of chlorophyll pigment, pigment A, chlorophyll A. So how this chlorophyll A can be determined from the satellite image? We have different sensors like ocean color monitor. I will show you some of the listed sensors wherein you can study them, the presence or absence of chlorophyll within the ocean. So, for example, you can see these are the phytoplanktons, single cellular and multicellular microscopic organisms present in the water. And when we have this type of water, what is the behavior of the wavelength, different wavelength? So you can see the clear water wavelength and algal and water with rich proportion of algal and other phytoplanktons. You can see the variation in the curve. The presence of this curve indicates the presence of the phytoplanktons, microorganisms with very rich presence of chlorophyll A. And especially, if you can see here, the uh, wavelength between 400 and 500 nanometers, where there is very strong absorption of the present, chlorophyll A in these wavelengths. So likewise, we have 675 nanometers, and based on these wavelengths, you can study, you can find out the presence of chlorophyll within the ocean. And the percentage of presence of algae also you can see here, 500 milligrams per liter, and you can see the curve. This is entirely different from the curve what we have seen for the sediments. So each and every material, they behave differently in different wavelengths. Here you can see the wavelength between 700 and around 700. You can see the presence of very high concentration of this. If you have this algal phytoplanktons in the water, you can see the curve rising here in this region around 700 nanometers. Whereas in 600, 580 and 600, you can see another peak. Based on these peaks, you can pinpoint with accuracy the presence of phytoplanktons in the water. And similarly, the chlorophyll. How do you estimate the chlorophyll contents within the water? And we know the different wavelengths. We have seen the wavelengths, and we have different algorithms for this analysis. We have selected one small algorithm here. This is the wavelength here. You can see 443 divided by 355, and this especially from the sensor called as the C-WIFS. That is C wide field sensor. WI means wide, F means field, S for sensor. So this wide field sensor, we have special bands in these wavelengths. So if you can, take out these wavelengths, this lambda 1 indicates the first band, and this is second band. If you take the ratio between first and second band, we get the proportion of chlorophyll present in the water. So this is how this is like this. We have number of satellite sensors from which you can measure the presence or absence of chlorophyll in the ocean water. And these are the sensors I was talking about. We have coastal zone color canals, OCTs, and polar the sea waves, OCI, then OCM, ocean color monitor, MODIS. Since there are so many satellite data, all of them, they are available for free. You can download from any of their website. You can visit their website, download them, and you can analyze the presence or absence of chlorophyll content near river region. If you have any ocean, you can take up the coastal region, and you can study the presence or absence of chlorophyll. Likewise, we have the algorithms for each and every satellite image. We have the satellite data here, the number of sensors present available, and based on them, we have the algorithms also. You can use these algorithms for the study of various purposes. The chlorophyll, you can see sea waves, and there are different modis. For example, they have their own algorithm. You can exactly use the appropriate wavelength, and you can analyze the presence or absence of phytoplanktons. And this is one image taken, for example, and they have studied the presence of phytoplanktons throughout the globe. You can see a very high concentrations of these phytoplanktons. You can see them near the land surfaces, land region. Wherever land is there, there adjacent to the land, you can see the presence of this chlorophyll and phytoplanktons. So like this, you can study near your region, take up, download the satellite image, and daily basis you can download and you can study, and also you can analyze the presence or absence of chlorophyll content in the water. So these applications are there. You can get it. You can measure the amount of chlorophyll present in the grams per cubic meter, and all these things you can study using this data. Along with this, dissolved oxygen matter. See, dissolved oxygen matter, along with the chlorophyll content, we also have the presence or absence of dissolved organic matter. So what is this dissolved organic matter? Like inland water bodies, when there is water stagnated in one place, lot of nutrients they generate. So those nutrients, due to biological or chemical or any physico-chemical reactions, they dissolve in water, and thus you can get the color, different color in the water depending on the presence or absence of dissolved organic matter. So when there is sufficient dissolved organic matter, so the penetration of light also reduces very greatly, and based on those amount of light that goes inside, based on that you can study exactly how much dissolved organic matter present in that water. So likewise, what type of dissolved organic matter you can expect. We have the humic substances, like yellow liquid what we get from the humus. So when it enters the water body, it definitely alters the color of the water. That is called as the yellow substance. So that yellow substance, it greatly absorbs and scatters the water in different wavelength. So based on this, you can study the presence of organic matter. And you can see here, there are different applications, different studies. This is one example I've taken, the mapping of sea surface temperature depending on the presence or absence of this organic matter and dissolved organic matter. So everywhere you can see in the northern polar region, colder climate, in the center equator, you can see there is the variation in the temperature. So like this, you can study them, across the globe. You can download this image and study. And likewise, you can study season wise, date wise. You can download any type of the image and study them depending upon the requirement of the study. And after this is the basic theoretical part of the water, what you can study. Now I am going to talk about the watershed. This is the most talked about topic in the present day situation. Is the management of water is very essential, very necessary, and you can see, what are the requirement for this. One very important aspect in this watershed delineation and mapping is we require a digital elevation model. So that is called as the DEM. So most of the DEM we have, if you open any Goan or any ISRO websites, the DEMs are available for free. There are a lot of satellite data which gives this digital elevation model. You can download them. That is the first step if you want to work on the watershed management and the management of water resources in on land. So this is the first step. You can download the elevation model, and there are different procedure steps for the delineation of the watershed. Here, we have to do a lot of pre-processing, analysis we have to apply, like flow accumulation for removal of pits. If there are any abnormalities in the dam, then those processes you have to finish them, and then you can delineate the watershed. So we will study them one by one. There are different aspects. We can delineate the watershed using the professional topo sheets that are available with us, and this is the tedious process because you have to map them manually. And if you have digital elevation model, you can definitely download them, and similarly exactly like how you do it manually, with more accuracy you can do it using satellite images, especially the digital elevation model. So then even you can delineate the drainage pattern, drainages from them without even drawing single line on the map. So here in this case, if you are using topo sheet, you have to trace the presence of the streams, and then you have to study the this watershed. You have to manage the watershed. But in satellite image, there are no as such drawn streams, but you have to extract them using different methods. So one such method is the terrain analysis. So there are different pre-processing techniques, what I have told you earlier, like sink removal, then field derivation, that flow derivation, calculation of the flow based on the derivatives. All these things you can do it one by one manually. So if you take the satellite image, if you can expand, if you expand the satellite image, that image will be represented in the form of pixels. This one example is here. There are 3 pixels in a row and 3 in a column. We have 9 pixels here. And for example, this 30 represents the size, means it is in the in meters. This is 30 meters. And the number represents the height. In the digital elevation model, the number on the pixel represents the height of that particular area. Whereas in normal ordinary satellite, the digital numbers represent the reflectance properties or the land use pattern present on the surface. So this and that is entirely different. This is, it gives the 3D, three-dimensional aspect in the form of height, whereas that the other optical satellite, they give the number which represents the land use pattern. Like for example, water, the vegetation, crops, so many land use patterns it represents. So each one it represents the height of that particular cell, particular pixel. So you all know the flow of water, the property of water, it flows from higher elevation to the lower elevation. For example, one center pixel I have taken here. The center pixel has the elevation of 67 meters. Surrounding to this, there are many pixels, but the lowest elevation is 48. So therefore, water tries to run more precisely to the 48 level instead of 56. Here also it goes 56 and 52, it goes even 60, it can also flow towards 56. It can flow any direction. So this is the principle, basic principle, and the deepest descent it will take, and it will go accordingly, as per the height and elevation. So you can calculate, based on this, you can calculate the slope. There are different small equations you can apply, and you can calculate the slope in the form of percentage or in the form of the degrees. You can do it. Either way, you can do. And this is the diagram, the extraction of delineation of the watershed. And this is called as the 4-point model. So what is this 4-point model? We are going to place a point on the satellite image to extract the entire watershed basin. So here we have the, again, 9 pixels with different numbers starting from 1, 2, 4, 8, 16, 32, 64, and 128. This is not just simply a number, but it represents the direction. Okay, if it flows towards 1, it is in the east direction. If it flows towards 16, it is in the west. 64 is the north and 4 is the south. And other regions like northeast, northwest, southeast, southwest, like that, it represents the direction. So wherein the software it decodes based on this principle. So this is the principle of 4-point. And from each pixel, from 9 pixel, I am going to take little bit higher one, bigger one. And each cell I have told you, the water flows from higher elevation to the lower elevation. So here you can see there are some numbers. For convenience sake, we have taken some numbers, and each arrow represents the direction of the flow. Which direction the water is flowing. So it doesn't mean that it has to flow only in one particular direction, but wherever slope, wherever the height, it the water goes in that particular direction. If the lowest height, it runs towards that lowest height. If it is moderate, flat, the less water goes. And the arrows represent the direction where it flows. Most of the direction you can see southeast, some of them in the south, some of them in the south. East and southwest direction. So all these arrows represent the direction of the water flow. Okay. So based on this direction, you can derive a lot of properties, physical properties. Based on this, you can see the color. From this color, you can see which direction it is flowing. See, most of this, red color here, it represents 128. 128 means it is flowing in the northeast direction. So the direction of water flowing is towards northeast. So like this, each and every direction you can measure by using the digital elevation model and with the help of appropriate software. And then this flow direction, can be prepared in the form of grid network. So what is this grid network? Each direction can be aligned, can be joined from one pixel to another pixel, and it gives in the form of grid network. So here you can see each line is joining in the form of network. So this is called as the drainage network. And each point you can see there are different points here. These points are, in any layman's term or in any ArcGIS, you can call them as nodes. So each node represents the point and a number of the points joining there. For example, if this point, if you take three nodes are joining, the number will be three here. Likewise, here is the number is two. Here also is two. You can see in the next diagram. Zero represents the starting point of the water body, and the 2 represents the 2 nodes. Likewise, the 3 represents 3 nodes joining together. So 11 represents the 11 points. All these things put together, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this 11 represents. So likewise, the software generates number of nodes joining in that particular point. So based on this, you can derive the grid network gridded pattern like this. So you can see the grid very clearly, and you can also give different colors for the different nodes. One, you can create different stream network also depending upon the nodes. One represents the first order stream, two represents the second order. Like that, you can create different order of streams. So all these things, you can give threshold. Here we have given 5 cells threshold here, you can see, and based on this, you can also derive the accumulation, the water, where the water is flowing in which direction. So all this water you can see in this diagram, the water it is moving and it is flowing towards the southern part, and this you can see in the red. That is the region where the most of the water is accumulated, and hence it goes out of the watershed. So this is how you can generate a watershed. This is manually, again coming back to that topo sheet what we were talking about. The lowest point, every watershed will have a lowest water point where the water is leaving that particular watershed. If you can place a point on that, this is the point, exact red point you can see. If you place the point on the lowest level in that region, it can demarcate the boundary of that watershed. Exact boundary it can demarcate. It will draw the boundary for that. So every watershed has a catchment. So that entire catchment is mapped very thoroughly like this. So this drainage analysis, you can do each pixel and where it is going, and the red being representing the lowest point in this image. So that image will give you the exact boundary, the exact watershed boundary you can demarcate. So like this, you can also demarcate the drainage pattern. So each drainage pattern you can join, like what we have seen in the earlier diagram, different nodes. It can be joined and it can be demarcated. So similarly, we have again you can see stream segments. Like I have told you, you can calculate the different streams. These are all very important aspects in the management of watersheds. So we have to find out how many of them are first order, second order, third order, fourth order, and based on that you can derive like this. This is one example. So from the previous diagram, like this, if you can take the digital elevation model, it can demarcate the entire region along with the number of river streams present in that region. So if you can just, this is one image, one portion blown out here, you can see different colors. Different colors represent the different stream orders. So starting from first order, second order, third order, two first order will join together to give second order. Two second orders will join together to give the third order. So like that, different streams can be joined together to give different stream orders. These are all very important aspects in the management of watersheds. So like this, grids, all these grids, it can be vectorized, rasterized. So all these things you can do in a software to prepare the channels or the stream length or the stream number of streams present in that particular area. So these are all the procedures and how it is done with the help of core points. You can see, you can calculate each node, different streams are given here in the different colors. So based on these colors, you can demarcate the different, streams with different, like order, stream orders, first or second or seventh order, eighth order, whatever order it is. So we know about the catchments now because the 4 points will demarcate the catchment region. For every catchment, every stream will have a catchment. So that catchment, is the place where the water will go into that stream. So if the water falls on the border of the catchment, it may go into the other watershed or it may come inside this watershed. So this is the water divide, we can very clearly say. So each catchment, I have told you very earlier, it will have only one outlet. So watershed, if I want to study about watershed, so watershed, here you can see the dam grid and the catchment grid. Each number is given here, and you can. This is the vector form polygon. This is the raster zones. This is directly derived on the satellite image, and from this satellite image you can extract in the form of vectors for the analysis purpose. You can do a lot of analysis on this. So you can measure the area, you can measure the drainage pattern, length of the drainage pattern, how much water it carries, and how much sediments it carries, or erosional aspects. All those things you can study using delineating of these watersheds. So this is an example. You can see the river, what you have seen in the earlier slide. It is now divided into number of watersheds, sub-watersheds, micro-level watersheds. Each watershed, you can see it has some area to it, and that area is called as the catchment for that particular watershed. So based on this, you can analyze each and every watershed. You can manage the water you can manage the water appropriately and properly. So like this, there are different catchments in each river basin. So I'm going to take up the case study. You will understand better. So once if you do this analysis, these are the basic steps required for the management of water on land. Any analysis, anything you can do. So there are lots of applications. Once if you do this, I will talk to you, in coming slides about the applications. Summary you have just seen. The pre-processing techniques like flow direction, flow accumulation, stream definition, stream segmentation. So all these things will give you the watershed like this. So this watershed you will get, and these are the procedures you have to follow to delineate. So these are the ArcHydro tools. In any of the ArcGIS software, you can use them. This is from ISRI software. You can attach this to any of the, if you have any open source GIS packages, you can attach to it and you can use them to extract the drainage pattern, and also they extract the watershed of that particular area. So drainage density, this is also a very important aspect because it controls a lot of other features. So drainage density also you can calculate. These are simple equations we have. So apply these equations to calculate the exact drainage density. So there are a lot of applications for this. If the drainage density is very high, the water inflow, accumulation of water will be very high. If the drainage density is high, soil erosion also will be very high. So there are so many aspects, basic aspects you can cover once if you analyze this drainage density and other, morphometric features. So these are the features, you can extract the drainage pattern like this with 100 grid cells threshold, 1000. You can give appropriately the amount of threshold starting from 75 up to 1000, depending upon your study. If you want to study micro level, you can give up to 75 also, the threshold, grid cell threshold, so that you can analyze it properly. And if you want to work on the large scale river basin, very huge river basin, you can use the 1000 grid threshold so that you can get the appropriate drainage pattern. So one case study I was talking about, what are the applications, of remote sensing in water resources. For this, we have taken, this is one of my research work carried out, and it is also published. And this is the watershed basin called Dodada watershed basin in Tumkur district, sorry, Chitradurga district. So this is Chitradurga district, you can see, and the watershed here, and the lat long location where exactly it is present, and the drainage pattern what you are seeing inside, it is all extracted by using a digital elevation model. You can see how beautifully it is extracted with the very accurate, the extraction of the drainage pattern are very accurate. So therefore you can rely upon this method, technique, for the analysis of watershed, and also the management of watersheds. So this is the case study I am going to take up. From this case study, what are the analysis, what are the parameters, variables we have used for the analysis of this watershed, I am going to talk about now. So first thing is that download of the images. The images, we have different sensors available with us, Landsat 5, 7, 8, and IRS series of satellite, and there are different satellite data available for us. You can download them freely, and all those satellite data, they come with different wavelength and different bands. For example, Landsat 8, it has 12, 14 bands. Landsat 7 has 7 bands. This Landsat 5 also has 7 bands. You can download them and you can work them appropriately depending upon the requirement. Here, I am going to talk about the watershed management. What are the things we can do in this? So one case study, what we have taken, this management of Dodala watershed, and we have seen, we have taken this satellite image, we have taken thematic mapper, ETM, and Landsat 8. Okay, these are the satellite images, 3 images we have taken, and we have taken data from Bhuvan also. This is freely available. Bhuvan is a ISRO website. From there, you can download almost all land use pattern of India. So these are the pre-processing techniques we have used, and this is a flow chart you can see. NDVI, NDBI, normalized differential built-up index. This is normalized differential vegetation index. This is water index. Then we are extracting water bodies from this land use land cover pattern, which is already extracted. We use as a reference to find out whether the analysis what we have done is very accurate or not. And from this, we are going to map different land use pattern like water bodies, forest area, then Kharif and Rabi crops. These are the broad classification we are doing. And once if we classify this, in this Rabi and Kharif crop, we can individually map the respective crops. What are the crops grown in that watershed? So finally, we are going to prepare a level 3 class classification. We have different levels. Level 1 is a very huge scale map, and level 2, level 3, they are considerably good scale with 30 meters resolution. And level 1, maybe it may be 250, 300, 500 meter resolution. So if further you can go up to one more level, up to 4, 5 meters, 4 meters, that is level 4, to 1 meter you can go, that is level 5, that is the final stage you can go. But for our analysis, since the watershed is very huge, very big, we are using this mid-level LULC class pattern. So with the level 3, that is sufficient for us for any type of analysis. So these are the data we have taken, and how we are going to work on this, management of watershed. We have different data starting from 1994 with up to 2000, 2015, 2020. You can download the images, even recent yesterday's image also you can download, and you can compare the different land cover pattern starting from those years, and how they change and what are the changes that has taken place. So for this, we have downloaded satellite image, and from this satellite image, I have told you, you can calculate NDVA. So this is the first step here. You see NDVA here. So like that NDVA, this is normalized differential vegetation index. The speciality of this vegetation index is it can map the presence of vegetation on the surface. The red color here, wherever you see the red color, it indicates the presence of vegetation. Blue color, it represents the absence of vegetation, that is, represented by water, where there is no vegetation at all. So I'm talking about land now. I'm not talking about water, presence of chlorophyll or not. I'm not talking about that. And land surface vegetation we are talking. So based on this, you can classify the presence or absence of the crops or the vegetation based on NDVA. Just NDVA you can do it. So then after this, we are going to analyze the NDVI with the different crops, cropping pattern. So for example, Kharif and Rabi crops. So Kharif and Rabi, there are two different seasonal crops. The Kharif crops, they are grown during June to December. So that is Kharif, and Rabi during summer season, that is May, January, starting from January to May. So based on those seasonal aspects, you can map the exact cropping pattern present in your region. So after this, different vegetation, after the classification of these crops further, we can also classify. I've told you the presence of water. There's one more parameter algorithm called NDWI. This is normalized differential water index. And this water index, you can see, we have just analyzed how much water was present during 1994, during 2000 and 2014, like even to the present day, how much water was there and how much water is present now. So all those things you can analyze. See how much water now in large scale, when the development takes place, lot of water bodies will go, as with different land use pattern. For example, in city, you can, for on the pretext of development, they can build lot of houses on the lakes and other things that has happened in many of the cities, very big cities. So those things can be studied. So if you can download satellite images for 30, 40 years, so from then till now, how much water bodies they have changed. So those things you can study. You can, like this we have done. And ultimately our aim is to prepare very accurate, appropriate land use land cover map. So that is very important for watershed management. So here, this is another index I was talking about, the built-up index. So this built-up index, red part, it shows the presence of the villages and the built-up region. So you can see very accurately it has mapped. Even villages, you can see a lot of dots, red dots on the image. So those represent the presence of the built-up land, villages. So very accurately you can map the water bodies, very accurately you can map the presence of built-up lands and villages. And then you can, of course, map the vegetation by using NDVA. Once if you do that, those are three basic steps. Once if you do that, and that land use vegetation pattern, you can go further and classify. So this you can see the NDVA pattern from 94 to 2014 and up to 2020. You can see how the differentiation is going on here. You can see the various pattern here, the analysis you can do, the changes in land use land cover pattern, all those things you can do very accurately. How much crops are grown in that region, and what is the present amount of NDVA present during those years. Based on that, you can analyze the crops grown in that particular region. So our aim is to prepare the land use land cover map with four major land cover features like Rabi crop, Kharif, forest, and water body. So we have to delineate, I have told you, whatever vegetation, including it is forest and the garden crops, cultivated crops, along with the crops grown. So those things you can map very accurately, because we have different procedures, different steps to map the forest region and to map the crops grown in that particular area. Very accurately you can map them, and based on that you can analyze, and this is our final map. And from this final map you can see the plantation crops, Kharif, Rabi crops, then the crops grown on the both the times, sometimes, we grow three crops in a calendar year. Every 4 months we grow, and sometimes we grow two crops. Sometimes we grow only one single crop per year. So paddy actually is grown twice a year, so that can be mapped. And likewise, the crops, other crops which can be grown every 4 months can be mapped very accurately here. So these are the maps we have done, and very accurately we have covered each and every aspect. And once if these maps are prepared, then only our water resources applications come in. So we have done all the maps here, the land, built up land, agriculture, and the wastelands, water bodies, forest, everything we have mapped here. So after mapping, our next step is the watershed management. Very important aspect of watershed management is the amount of water that is coming into the watershed. So rainfall, we get rainfall normally, if you go and get the rainfall, we collect in terms of millimeter data. So we say one region it has 5 millimeters, 4 millimeters of rainfall, and the data we collect and throughout the entire watershed regions. Nowadays, every village has the point where we can collect the data. So that stations we have wherein the data are collected. So we have government of Karnataka. We have our own weather stations. Likewise, the drought monitoring cell, ISRO. Everybody has their own weather monitoring stations. So rain gauge stations also we have. So we collect data from all those stations and we use for our analysis. What is our aim? Our aim is to find out. See, this is our watershed. Okay, this watershed. How much water has come into this watershed and how much water is it is going out of the watershed. So coming in is the only source is rainfall. Okay. And going out of the watershed, there are different sources. Like evaporation, it can happen, runoff, it can happen, percolation, it can happen, underground water flow, it can happen. So many things can happen. So all those things you have to analyze how much water, what is our aim? We have to find out, this. For example, we can instruct the farmer to grow what type of crop because the depending upon the water, we can tell them. So otherwise, if farmers grow crops and there is no rainfall and no sufficient water, the farmer will be under tremendous loss. So therefore, we analyze the presence of water. That is the reason why we are doing this runoff modeling. Runoff modeling is to show that how much of water is accumulated in a watershed. So there are different procedures for this. We collect rainfall data, and in this we especially we have collected rainfall data from satellite itself. We have TRMM, Tropical Rainfall Measuring Mission. This is the satellite data. We collected data, rainfall data from this, along with we have IMD rain gauging stations, and also along with we have other agencies which give us rainfall data. So with that rainfall data accurately, we can calculate how much water has come into the watershed. So based on this, analysis, again, I'm showing you the flow chart. What are the, how we are going to model, how we are going to find out how much water has come into the watershed. So these are the procedures again. Similarly, you can see topo sheet or DEM, the digital elevation model. From this, you can find out, and along with the HEC and HMS model, software, we are going to find out the runoff. And this runoff will give the exact amount of water that has come into the watershed and the amount of water that is going out of the watershed, including evapotranspiration. Evapotranspiration during summer it will be very heavy evaporation and evapotranspiration. During winter it will be very low. Likewise, summer, the runoff also it depends upon the land use pattern, how much water we are using. So all those parameters we have to take it into consideration for find out the amount of runoff. So based on this, there are different procedures. In Dodala, you can see we have demarcated different various sub-watersheds. Each watershed contribute water. From this, we can measure which watershed has contributed large amount of water and how much quantity, how much, how many water, how much water has contributed. All those things you can measure very accurately nowadays. You can see the amount of water every day. If you open newspaper, you can see the mark of each and every tank, how much in dams, how much water is stored in the dam. Very accurately we can say in the form of TMC, in the form of cubic meters, whatever it is. So that water, how much water has come in, how much water is going out, that also you can measure. So normally you can see inflow and outflow. Inflow in the form of Q6, outflow also in the form of Q6. So those things you can measure, those things you can record on daily basis. So how much water has come in and how much water is going out of the watershed. So this is one example we have taken, and this is the entire river basin. This river basin has this watershed. You can, if you can see the watershed in the entire river basin. So this is the river Vedavati river, and this river, it originates in Karnataka. It goes and joins the Krishna river basin. So this is the river we have taken, and why we have taken, why we have we want to study this, because we wanted to find out how much water is contributed from Dodala watershed. So for that, to measure whether our study is very accurate or not, we have to collect data from rain gauges. So this Central Water Commission and other agencies, they have this rain gauges, sorry, this water gauge stations. They can give us very accurately the data, how much water is flowing out in the form of Q6 or in the form of the exact amount cubic meters they can give us. So with this help of this water, this data, we calculated how much of water is contributed from our watershed, Dodala watershed. So for this, we have applied different techniques. We have collected rainfall data. We have collected different, like I have told you, evapotranspiration. We are using surface energy balance algorithm for land, SEBAL, SEBAL. So this algorithm will give us the exact amount of water, how much it comes in, how much it goes out. So it also calculate the evapotranspiration and other aspects, land surface temperature, everything it can be calculated from using this small software. So this is how, we use different parameters for these variables like NDVI. So along with this NDVI, we have different vegetation indices like soil adjusted vegetation index, so leaf area index. So we all calculate, using different land use land cover features. That is why our first aim is to calculate the land use land cover features. So once if you calculate land use land cover, all these secondary steps, they become more easy for you to create a model. Exact model you can create for the management of watershed. So once all these things are done, we can calculate the land surface temperature. So exactly land surface temperature, these are all calculated using satellite images. It is not like, data what we have taken from the weather monitoring station, not from the temperature thermometer. This is calculated using satellite images. So these different parameters like albedo, how much energy comes in from the sun, the long sunshine hours, all those things, wind direction, wind pattern, flow of wind, speed of wind, all those things we take into account, and then we prepare the exact amount. This is another example of heat flux, calculated during different months, different periods. So these are all the different images what we have collected to calculate evapotranspiration. This is our final, step, because we have to calculate how much water is escaped from the soil. So all these things you can calculate, and finally you can prepare a model. So here you can prepare a model, and we know the runoff, how much water has accumulated, and how much water is in the form of evapotranspiration, and how much water is flowing, and how much water is going down in the form of groundwater. So that also we can study, because groundwater, it requires the soil data. So that soil data along with this other land use land cover pattern, here you can see the major crops grown here in this Dodala watershed. All these major crops have been mapped, and our aim is to find out exactly how much water we are going to use for these crops. So that is very important aspect of watershed management. So these are the total area, cultivated area of different crops. Okay, and now the next part is the calculation part. So, for example, I am going to study groundnut, ragi, maize, jawar, and sunflower, and I wanted to find out how much water these crops they use for their entire growth cycle. So now, for example, I am getting 5 millimeters of rainfall in one watershed, and that 5 millimeters of rainfall, how much water is, it accumulates, how much water it can be, this rainfall in millimeters can be converted into volume of water. and that volume of the water, after calculating the losses and gains, then we can use that for the analysis of these crops. So each crop, how much the crop uses that particular water can be analyzed. These are the steps we have followed and different procedures we have. And once if the procedures are followed, exact crop requirement, each of the crops, these are the steps like evapotranspiration, calculation of evapotranspiration and crop coefficient we have to calculate. Once if all these parameters are ready, and depending upon the period, you can exactly pinpoint with accuracy how much water is required for each and every crop in terms of millimeters. So that can be measured, that can be calculated here. So these are the values we have calculated. You can see each during each season, you can see sowing season, harvesting season, and exact amount of water, how much water is required in the form of millimeters, you can calculate them. So once if you calculate, you can, this is how you can manage the watershed. There are different steps here. You can see planning and managing the development practices of watershed. So development practices means, for example, farmer, he needs to grow a crop, and if he knows how much water is accumulated in the watershed and how much water he has at his disposal, so based on that he can grow crops, so there will be minimum loss in the production. So that you can calculate. And also we can calculate, because rain fed also agriculture is very important. Rain fed agriculture, because we farmers, they entirely depend on the rainfall, that is in the kharif season. So along with the rainfall, we can calculate, take for example 50 years, 100 years data. You can measure the average rainfall, how much rainfall it comes. So with the accuracy, up to 70-80% accuracy you can expect. So like that, you can manage the different watershed. This another flow chart. So here you can see the major water inputs. We have rainfall and water budget, in the form of runoff. So all these things, soil infiltration, these parameters we have to calculate to exactly find out the pattern, cropping pattern, and how much water is required for each and every crop. So all these things, all these parameters we have to calculate, and then ultimately come to conclusion the requirement of water in that particular watershed. So based on this, we can prioritize the watershed also. We can say which part of the watershed, contributes large amount of water, which part contributes for the soil erosion, which part contributes in the form of rainfall. All those parameters you can, characterize here. So that is called the prioritization of watershed, sub-watershed. You can map, you can very clearly say how much, is contributed from each of the sub-watersheds. So this is how very accurately you can calculate. And I've told you the infiltration. So if for infiltration, we need the soil, the texture of the soil. So based on the texture of the soil, you can find out how much water is infiltrated in the region. So that is also, it amounts to the loss of the water, incoming water. Incoming water, I have told you, only rainfall. So the other water, evaporation, evapotranspiration, that all comes under loss. And this also, the percolation of water, it goes into the groundwater. So that also, you can calculate and you can extract later the groundwater. So these are the resources, water resources you can, and with other parameters like LULC, rainfall pattern, the slope, I've told you slope is very important, and the drainage density, and the geomorphology of the region, and other physico-chemical parameters, you can very clearly say, accurately say the, you can manage the watershed. And also you can appropriately suggest the water harvesting structures. Most of the regions nowadays, it has become very common that, the region in watershed, it is preserved, and the water is stored. They construct some artificial harvesting structures to minimize the soil erosion sometimes, and also to store water. So these water harvesting structures you can recommend along with the management of water resources, and also the cropping pattern. So you can always guide the farmer what type of crops he has to grow depending upon the availability of the rainfall and availability of the water. And crop requirement also you can highlight, because each crop requires water. For example, paddy is such a crop that it requires very large amount of water. So that water you can guide the farmer how much water is at his disposal, and how much water is required for the growth of that particular crop. So all these things you can analyze using this watershed. Hello? Yes. So then the other aspect here you can see the management, and each and every crop you can see we have classified each and every major crop that is grown in that particular watershed along with other land use features. And based on this you can manage them very well. And thank you for your patient listening, and I will take up some questions, and if you have anything I can clarify.
Thank you very much, sir. So there are
I
two
hope all
queries.
questions are followed, and I will take up questions for any clarifications if they have.
Yes, sir. There are two queries, sir. One is how the flood disaster and earthquake disaster be studied using remote sensing and GIS.
Yes.
Is a flood
Then can you
disaster,
repeat it?
flood disaster, and the earthquake
See,
disaster.
flood also, the flood disaster, floods also, we have worked a lot on floods in Bangalore, in northern Karnataka. So that also same procedure, same runoff, runoff, that if you can study, you can manage floods also. Because runoff, it gives the basic data of how much water, excess water or deficient water, so that you can study.
So one more question.
Yes, definitely you can analyze floods. You can analyze floods. You can analyze anything drought. You can analyze deficient water, excess water. Excess water leads to floods. Deficient water leads to drought. So all those things you can study. You can manage the watershed very accurately.
Yes, sir. One more question is, can we use this hyperspectral data for water-related study?
Yeah, definitely. I see. I've told you I did not touch, because hyperspectral, the whatever the images I have seen in my earlier, first few slides, they are all hyperspectral data. So that hyperspectral data also is available for free. You can download and you can use for your analysis. We have this different satellite, different sensors we have. So those things you can download.
And one more is,
Definitely
apart
hyperspectral. Yeah.
Apart from
Please go ahead.
SCS curve method, which are the other methods of calculation in the catchment?
No. See, SCS curve is one of the method. Okay, SCS is one of the standard method. You can use. There are different methods. I have told you. Along with SCS, I have shown you some packages. They also use SCS. Okay, SCS curve is a standard method, and along with the digital elevation model, I have shown you some diagrams. So those things you can use for the analysis, and you can derive the runoff. You can do a lot of work, if you have digital elevation data.
So last question is, can we use the estimate the exact groundwater contribution from infiltration rate?
Yeah, see, infiltration rate, I've told you, I did not concentrate much on the infiltration. See that soil, we have done in-depth analysis. If sometimes, I can give presentation later on the infiltration and the management of groundwater. So only major aspect what I have concentrated on the surface water. So I have also shown you the soil type and texture. Each soil type will have different infiltration property. So clay soil has different infiltration property, loam, sand. So all those things, once if the water comes to the surface, depending upon the soil, we can exactly calculate the exact amount of water that goes inside. So inside the ground. So that infiltration you can very accurately you can calculate how much water goes inside, and you can accordingly you can prepare different water harvesting structures.
And last question is, can we differentiate between sediments, phytoplanktons, and zooplankton, sir?
Definitely, see, that is why I've told you zooplanktons and phytoplankton, they are biological parameters, and sediment, they are inorganic parameters. So sediments can be studied in different way, different wavelength, and biological parameters can be studied using different wavelength. So those wavelengths, definitely will help you to identify the type of parameter, and also the type of these phytoplanktons, whatever you have, you can map them very accurately. That is the reason why, early in the morning, if you go towards coastal regions, they will alert the fishermen. You can see, open the any website, they will exactly let you know the presence of chlorophyll content in that particular region. So the fishermen can go to that region and to catch fish. So that type of alerts you can give. Definitely, chlorophyll presence or absence of these phytoplanktons and chlorophyll in the ocean water will definitely help you in mapping these things, and also advise the fishermen to go and catch the fishes. Yes, anybody else?
And lastly, one question has come, sir. How much remote
Yeah.
sensing data is required for the land use land cover preparation? Is base map
See,
required
land use
for
land
the
cover.
base map
See,
required
not
for the
how much,
calculation of it, sir?
see, one image, one or two images you can download. See, land use land cover pattern, it depends upon your requirement, your study. If, for example, I want to work on the cropping pattern, I want to work on a particular crop, for example, paddy or some crop. It has a cycle. Every crop has 3 4 months cycle. So depending upon that cycle, you can download different images with different, spatial and temporal resolution, and based on the resolution, you can work. Definitely, you can download, every cropping pattern, it has weekly images, daily images, monthly images. You can download once in a month. If you want to study in depth, in detail, weekly is the best option for you. Weekly images, for example, to study any cropping pattern, the use of water resources weekly, you can opt. Then you can prepare land use land cover map accordingly.
So one more question: from which satellite images
Then we
can
have
we have
linear. See,
linear?
lineament density. If you have, first requirement for lineament calculation is the digital elevation model. So digital elevation model is the basic thing you require, and based on that you can prepare the lineament maps. And also, depending upon the other satellites like Landsat, you can prepare lineament map. If you want to prepare lineaments using exclusively satellite data, digital elevation models are the best. You can use them because you can do it very easily, accurately. There are some steps and procedures, methods involved. You can map them.
Okay, sir.
Yes. Anybody else?
No more questions, sir. Thank you very much, sir. It was a very wonderful session. And
More. Anybody else who are? This is flood disaster, earthquake. They have asked.
participants can also interact directly with sir.
Yeah, you can always interact. I have given you my email. Phone number also you can take, and Ganesh has my phone number. You can interact with me anytime. Which are the other aspects to be considered for watershed management? See, watershed management, it is, the basics. What I have talked to you about now is the basic requirement. Along with this watershed, you can calculate the erosion aspects, erosion, how much soil erosion has taken place in that watershed, particular watershed. Like you have said, floods, that you can do. So there are so many things you can do. Management of water or this groundwater, surface water. You can do that contributes to the very accurate analysis of watershed. So that this thing you can do it. No problem. See, for this requirement, lots of satellite data are available. They are all freely available. You can go to any of the website. Any of the website, you can download them.
Yes, I think there is no
Anybody
more
else?
queries, sir. Participants,
Because all their mics are mute now. If you can give them access, they will talk.
they have been given the access, sir. They can unmute and they can ask the questions, sir.
Yeah, they can directly ask if they have anything, any doubts.
Any specific source for stormwater water data mapping?
Stormwater, see, that is, we have done this in Bangalore city. Bangalore city, we have a lot of this flood disasters every rainfall day. Any rainy day will give that we have done. This is entirely different topic. Other than, this is, today I was talking about watershed, but stormwater, that is different topic. Rainfall, there are different methods you can use for analysis. That will, take another 1 hour for me to explain about the method, how to map the stormwater. We have done that exclusively for Bangalore city.
I hope many of the queries have been answered by you, sir. So there is one more
We
question. Can we
classify soil based on remote sensing. The remote sensing based classification, we classify soil based on texture. Okay. Texture means, it depends on the grain size. So that mapping we have to do based on the analysis of soil. Remote sensing, you will not get exactly what type of soil, clay or sandy soil, that type of analysis we cannot do. But the analysis soil texture is only, it is the experimental data. Mapping, we cannot do exactly the mapping of the soil based on texture. Other type of mapping we can do, presence or absence of soil, those things you can do. Sandy soil, clay soil, loam soil, to some extent, to very small extent you can map, but not very accurate. So that is why we rely on the soil maps produced by Soil Science Bureau and other agencies. We cannot prepare. I have used almost all data derived from satellite image except for that soil data. Soil data we have collected from Soil Science Bureau because the maps prepared, it requires the texture. So we require the amount of clay, sand, silt, particles present. I hope I have answered your this thing question.
Yes, sir. Any questions else from the participants? There is no more questions, sir. So once
If there are
again,
no more questions, I thank Ganesh and the other organizers for giving me this opportunity to share my thoughts with all of you. And thank you. I welcome any type of comments in future. Thank you. Thank you.
thank you very much, sir, because I know how much busy you are with your work schedule. So you have spared your valuable 1 hour of time. So for which the Department of Civil Engineering, Jawaharlal Nehru New College of Engineering is always thanking you. Thank you very much, sir,
Thank you.
for a
Thank you,
wonderful
Ganesh.
discussion.
Thank you. Thank you. Thank you very much.
Thank you, sir. So the feedback link has been given in the messages in the Google Meet. So everybody are informed to give the feedback links along with the YouTube channel. Thank you very much.